Hey everyone, in this video we're going to be learning how to multiply polynomials. So I know on the screen it says that we are going to add, subtract, and classify as well, but we did those in our last lesson. So this is kind of part 2 of the same lesson. All right, so let's get started. So when we are multiplying polynomials, really what we're doing is we're just distributing, okay? So we call this a distributing method. Some people, when it's a binomial multiplied by a binomial, call it FOIL, and that stands for first, outside, inside, last, just to help you remember that you have to distribute everything. So here we go. We've got 4x times 2x. That's going to get me 8x squared. But now I have to multiply my 4x also by my 1. So 4x times 1 is 4x. Then I have to distribute my -3. -3 times 2x is -6x. And then I have to multiply my -3 times 1 to get me -3. So now that I've multiplied, I can take a look back and say, well, do I have any like terms? Because now it's an addition subtraction problem. And my like terms are 4x minus 6x, and that's going to get me a -2x. So there's my final for that problem. If we were to classify it, which was one of our skills we practiced last class, that would be a quadratic trinomial. All right, so this process works no matter what you're working with, okay, whether it's a monomial times a binomial times a trinomial, or a trinomial times a monomial. So our next example, we have a monomial, 4x squared, and we want to multiply that by 3x and by -2. So 4x squared times 3x is 12x cubed. Remember, when you're multiplying, you multiply your coefficients, you add the exponents of like bases. All right, and then you've got 4x squared times -2, which gets you negative or minus 8x squared. That would be a cubic binomial. Next problem, 4x times 3x squared is 12x cubed. 4x times -4x is -16x squared. 4x times 1 is 4x. -1 times 3x squared is -3x squared. -1 times -4x is positive 4x. And -1 times -1 times positive 1 is -1. And then if we go along, we should notice that we have a -16x squared and a -3x squared. Those are like terms because they have the same variable with the same exponent. So -16x squared minus 3x squared is going to get me a -19x squared. All right, and then we've got a 4x plus 4x to get plus 8x, and then we still have that -1. The 12x cubed I just brought down because it didn't have anybody to combine with. That would be a cubic polynomial. And then we got one more problem here. So we have 7x cubed times 2x, that's 14x to the 4th, followed by 7x cubed times 1, that's 7x cubed. And then -x times 2x is -2x squared. And then -x times 1 is -x. Now just distribute the 1. 1 times 2x is 2x. And 1 times 1 is 1. You only have -x and 2x as your like terms. Everything else stays separate. So I'm just going to bring everything else down, and then really -1x plus 2x is a positive 1x, or just x. So that would be a quartic polynomial. So let's talk about this special case. What happens if I give you a binomial and I ask you to square it? Well, because it's a binomial, I cannot distribute the exponent. I can't just say, oh, it's going to be 3x squared plus 16. No, that's a lie. All right, and you'll see why. So there's two different ways you can think about it. One is through a formula that I will show you in just a moment. The other way is just to rewrite as two binomials. 3x plus 4 times 3x plus 4. And now the problem is just like what we were doing above. So if you want to try one, take a moment, pause the video, try it on your own. So 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is 12x, and 4 times 4 is 16. So my final is 9x squared, right? It has nobody. 12x plus 12x is 24x, and then plus 16. There's my final simplified answer, all right, which is a lot different from if you just said, oh, distribute your negative, 9x squared plus 16. Actually, earlier I even made a bigger mistake and said 3x squared because I didn't even put the squared on the 3 as well. All right, so never distribute your exponent. That's bad math, okay? When we're dealing with a binomial, we can't do that. So this, when we multiply a binomial times a binomial, it actually creates what's called a perfect square trinomial. So there is a formula, all right? If it's a plus b squared, some quantity, some binomial, a plus b squared, the formula says it's always going to follow this pattern, a squared plus 2ab plus b squared. If it's a minus b squared, it will be a squared minus 2ab plus b squared. So if we take our last problem that we just did and follow this formula, all right, notice that your 3x is going to serve as our a value, and our 4 is going to serve as our b value. So we're going to be following this pattern right here. All right, so a squared, so that's going to be 3x whole quantity squared. Then it says plus 2ab, so 2 times 3x times 4. And then it's going to be plus b squared, so 4 squared. So 3x whole quantity squared is 9x squared. 2 times 3x is 6x, times 4 is 24x, and then 4 squared is 16, which is exactly what we had gotten over here before I had erased it. So you don't have to memorize this formula, but if you're one of those people who like some tricks and tips, there's your trick and tip. Otherwise, just multiply it out. Now, why do I even bother to, show you that? When I say, oh, you're just going to multiply it out. Well, what if I asked you to do 3x plus 4 to something higher than 2? Like, say, the 5th power. All right? Well, that's where this nifty thing called the binomial theorem comes in. And the binomial theorem comes from this special triangle we're about to talk about. So whenever your degree is something higher than, say, 2, all right, you might want to know this, all right? You're not going to be testing on it. It's just extra material, but here we go. So this triangle over on the bottom left that I'm circling, that is called Pascal's triangle. Pascal's triangle. Pascal, ancient mathematician, all right, who is we're told that he created this triangle. So this triangle is actually incomplete. It goes on forever. There's a pattern here. So notice we start with the number 1, then it's 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. How are we getting from row to row? Well, we start off with 1. Then we have 1, 1, because that's all that we have to work with. So every row will start with a 1, and then to get to the next row, what you're going to want to do is add the previous 2 to get that middle term, and then end with a 1. So if we wanted to do another row onto what we already have, all right, we're going to start with 1, then we see 1 plus 5, that's 6, 5 plus 10 is 15, 10 plus 10 is 20, 15, 6, and 1. Go ahead and try a final row for yourself. It would be 1, 7, 21, 35, 21, 7, and 1. Sorry, that was supposed to be a 35, not a 31. All right. So what does that have to do with what we were just talking about with this, squaring a binomial? All right. Well, I'll show you. So the first layer of Pascal's triangle, this one step, we're actually going to call it step 0. Then we've got step 1, 2, 3. Sorry, these are getting slightly uncalibrated. I apologize. But we're counting the first row as 0, then 1, 2, 3, 4, and so on. All right, so stick with me just a little bit longer. This is a good extension enrichment. So let's start off with just, whoa, that was ugly. I don't know what my smartboard's doing. What if we had a plus b to the 0 power? Now, I've told you before that we can't utilize, like power to a power and stuff when we're dealing with anything higher than a monomial. However, even if we had anything we wanted in here, a plus b, could be anything, and we did that math, eventually we would take this whole quantity to the 0 power, and anything to the 0 power is 1. All right, well, let's step it up a notch. A plus b to the first power. All right, well, anything to the first power is just itself, including my binomial. So I'd have 1a plus 1b. All right, let's go to a plus b squared. Well, earlier I told you exactly what that pattern is going to be, so we're just going to trust my pattern here. If you don't trust me, try to multiply that yourself. So we'll have a squared plus 2ab plus b squared. If you had to put a coefficient on it, you'd put a 1 on the a squared and a 1 on the b squared. I hope you're starting to notice some numbers here. 1, 1, 1, 1, 2, 1. So let's see if we can follow this. A plus b cubed. I'm going to use row 3 right here. Okay, actually it's row 4 if you're counting them, but that's for my cubes. All right, and these numbers, what are they giving me? Well, they're giving me the coefficients of each of my terms. Okay, and we should start noticing that when it's to the 0 power, there's no a's and b's. When it's to the first power, there's 1a and then there's 1b. When it's to the second power, notice it's a squared, then it's just an a, and then there's no a's. We start with no b's, 1b, b squared. So it looks like our first variable is working its way down in exponents, and our second variable is working its way up in exponents. And these are all plus signs because we're dealing with a plus b. If it was a minus b, we would just flip-flop the signs. Like it would start off positive, negative, positive, negative, negative, positive. I apologize. So there's a pattern there as well. But anyway, let's just go with a plus b cubed. So our highest power, it's going to be 1a cubed, no b's. Then it's going to be 3a squared. We're working our way down with the a's, and then a b shows up. And then it's going to be 3a to the first power, b squared, and then no more a's, and we're left with a b cubed. You could keep doing this. So if you wanted to find, a plus b to the 4th or 5th even, you could just follow this pattern. You would use whatever row you're working with, and we could keep going to wherever row we wanted to, and we would know our coefficients right away. 1, 4, 6, 4, and 1. They're all going to be pluses because we're dealing with a plus sign. All right, and then we start with our first variable to the highest power, a to the 4th. Then it'll be a cubed and a b shows up, a squared and a b squared. So b is working its way up, a is working its way out. So there'll be a, b cubed, and then b to the 4th. And we could keep going. Again, you're not going to be required to memorize this or put this to a ton of use, but it is very helpful in our upper level math classes when we need to find some binomial to a higher power. So that's multiplying plus a little binomial theorem fun for you.